In this video, we're going to have a crash course regarding what is the client-server model, which is a fundamental architecture for communications between devices over the internet and stuff like that. We're also going to check out what is a server, and for some people it might be really clear, but I think for people coming into IT, it's kind of confusing because you see this keyword in many different concepts. For example, you can see server applications like the Apache HTTP server, for example. You can see the server keyword in operating system versions like Windows Server, Ubuntu Server, stuff like that. And also you have a server as hardware, like a server computer. And I think it's important to distinguish the difference between what really makes a machine, a device, a server. Okay, we're gonna check this out. Also, we're gonna have a crash course in databases, like how do you authenticate, what are the basic components of a database server. There are many, and we're gonna do also an example with Python. We're gonna use a script to connect to PostgreSQL. We're gonna install the PostgreSQL database management system on Windows. We're gonna use the script to connect to it, write some data. We're gonna create some tables, add some rows and retrieve them, and see how we can just create programs that connect to databases given a URL and some credentials, and you can just use this to build upon your ideas. When it comes to the client-server model, I think it's pretty straightforward. There is a device somewhere in the world that is acting as a server, meaning that it's running some application that can handle requests from other devices that are sent from what we call the client, which is usually people, but not necessarily, operating some device that is performing requests in the given context that the server is expecting to receive. For example, HTTP servers use the HTTP protocol, which have its own specifications on how a request should be structured. They send them to servers and the server responds back, and we can see in our browsers, which is essentially a client application, to interact with web servers. And we can see the information we requested. For example, if I just open a new tab in Firefox now and hit the GitHub button here to connect to the GitHub website, I can see the content that I requested. This is the main page of the GitHub server, which is running somewhere in the world. I don't know where this could be. And this is how we're served with information, but not only. We can also use functions and many other things. For example, take this application that I'm using to create this graph. It's called Mural. Okay, so Mural is also a web server. It has a web server somewhere to be able to offer me through my browser this functionality. Right now it has loaded, and just to give you an example of what is happening in the background, because it's much more complex than just pressing buttons, I'm gonna use a toolset that all modern browsers offer. It's the web developer tools. It's a toolset for people building up applications that need to check a few things like what is happening network-wise, or they have some debuggers and a console to run JavaScript. You can see here there are some errors. This is probably interesting for someone that is building an application and he wants to check how it's running. So I'm interested in this network tab right now, and I'm just gonna show you something very simple. For example, this Mural has this functionality. I can just open this tab here. I'm gonna delete this request that is part of the example, but I just want to be more specific. So let's go back to 0. So it offers you the functionality to search for images based on keywords. This is how I found these images here, and I just drag them in my space. If I write, for example, let's go back to 0, Apple here, with 3 P's, it doesn't matter actually. You can see that a bunch of requests, this was automatically done by my browser. It was not only one, but like 6 different requests were sent. Some of them are analytics and, Google Analytics stuff that measure statistics about the usage of the website by users. So I'm gonna just do a filter here. I'm just gonna type Mural to just filter the ones that were more specific, let's say. And let's make it. Okay, whatever. So let's see what happened. This is the protocol specifics, like it was a post request against the server to some particular, let's say, resource. And let's see our request. It carries a query, okay, Apple, and some other information. This is the JSON structure. I'm not gonna talk about it right now. It's pretty simple. I'm sure you can just understand it by reading it once. And let's see the server response to this automatically made request, right? So check it out. It's just again JSON, and I can see some links that are leading to some Apple pictures like JPG, all these things that we see. And if I scroll down, you will see that automatically other requests will will happen, just to fill the gap, because I'm ending the space that was already allocated, let's say here with pictures, and it's just requesting for more and more, and as I keep scrolling, it's just retrieving more and more. And look how many requests happen in the background and how many information. I mean, there's a lot of data here, and I can just grab one and drag it in my space here. And this is a great example of the client-server model, and it's happening in the background. And it's this toolset here. It's very useful for web developers or even cybersecurity people, testers that want to do, you know, find tricky parts in an application. They can just monitor what is the interaction between the browser and an application in the background, and maybe discover new endpoints and stuff to mess with. With this simple introduction about the client-server model, let's check out what a server can be. Essentially, for a device to act like a server, it needs to be running a server application, meaning an application that can accept connections and process requests from clients in a specific context, as we saw before. And I think a very fast and easy example is the Apache HTTP server, which I believe it's pre-installed in every Linux distribution ever created. And I have a Kali Linux VM here, and I've navigated to var html, which is the default, the root folder configured as the directory of the server, meaning everything that is in here will be served when the server starts. And I'm going to run the service, the Apache service, the program service Apache to start. And actually, let's create a unique resource here. For example, let's create test.html and write something inside, like please subscribe, and let's just reload to be sure we can access this resource. And the IP of this machine is this one, and I'm gonna use my Windows host to navigate to test.html, and hopefully now it will be served and we can access it from different devices. There are of course many different server applications that can work in many different contexts. For example, SQL servers like the PostgreSQL we're gonna use later, the MS SQL, Microsoft SQL, a Minecraft server, for example, which is a server to host gaming like sessions, and people can connect and play together. We also have server operating systems like Windows Server 2022, Ubuntu Server. These operating systems are built with optimizations when it comes to resource management, reliability, security. They're more expensive, and usually we use them in devices that we want them. They're not like for personal use, like a laptop or something. There are devices that usually will be alive for a very long time until some failure happens, or it has to forcefully like stop working or something like that. They're not designed to, you know, take breaks. They're there to serve requests all the time. And we also have server computers, hardware, and if you have never seen one, I think it's really relevant for you to have an idea of what it may look like. This is a tower, an HPE ProLiant ML350. It's an absolute beast. And I'm gonna just show you a very quick video of how it looks inside, so you can understand a little bit. It has the same components as a regular machine, computer, but check it out. All of these are slots for hard drives. You can see it has an unlimited space, let's say. And if as the infographic moves on, you can see it has 2 CPUs and memory slots for each one of them. And actually, what is really interesting is that this is the power supply, and you can see there's another slot for a power supply. For example, I think if one goes down for any reason, the other one can take on and continue the operation. And let's check the back to be sure. Here. Yes, power supply 1, power supply 2. So you can see this machine is not designed to stop, you know, it's designed to just run for who knows how long. Taking in consideration all of these characteristics, I think there is a great question raised, like what is essentially a server? For example, let's say we have a laptop, your old laptop, the one you have Windows 7 and it's in some drawer inside, okay? And is it a server computer hardware-wise? No, it isn't. Does it run on a server OS? No, it doesn't. Let's say you have some kind of server installed with it, PostgreSQL or something like that, okay? And it's active, meaning that it can actually serve some requests. This kind of makes it a server. Essentially, it is a server, and it might be doing it poorly, and it might crash after like 5 requests, but it is a server device. And you may have a server computer, like hardware-wise, you bought this beast, for example, and you slapped Windows Server 2022 on it, and you're not running any service. You just have it there. You browse the internet and, I don't know, Facebook, something like that. Does that make it a server because it's server hardware or it's running a server OS? No, it does not. It does not serve any requests. So essentially, what actually makes a device a server is the software it's running, and not the operating system it's running on, or what is its characteristics in the physical aspect. So let's go over to databases and see what's the deal. If you have never used a database server, because maybe you have heard some admins talk and they say, hey, let's back up the database, or let's do this to the database, and this might give you the impression that the database server is having like one database, but this is actually wrong. A database server can have multiple databases. You can name them whatever you want. You can create as many as your machine can handle, the machine that is running the database application. And I think the most essential of the components that a database includes, because there are many, and even if you use a database system heavily, I think you will more or less, you will just handle privileges of users and data, which is stored in tables, and a database can have multiple tables, and there are many characteristics. We're gonna see a few, because we're gonna install PostgreSQL on my Windows machine, and we can create a database, some tables, some users, connect a program. This one will do it just now. Just a heads up, there are two levels of authentication in a database server. For example, there's the server level authentication, usually a super user, you know, usually it has the name of the database or something like that. And this user can change configuration, create new users, groups, delete, connect to other databases. It can do a lot of stuff. And there's database level authentication, meaning a limited, let's say, user that can access one or more particular databases in the server. And this is how usually administrators set accounts for applications, because, for example, this Mural, I'm just taking it again as an example, the web server probably has some user that is using to connect to another server, a database server, and store information, and you know, do these transactions that it needs to provide this interface that we are using. And we design this nice graph here. So let's get our hands dirty. Let's install PostgreSQL. I'm going to download for Windows. It should be this one, the latest version. And here's the executable downloading. Let's run the wizard. We'll hit next here. Next. This is a very important component. We're going to use it. It's the PostgreSQL admin. It's an interface to connect to the server. It's super awesome, and it will help you a lot to understand the structure of a database. So we're definitely gonna need it. We're not gonna need this, and let's finish. Normally, you should get prompt by the installation wizard to set a password for the Postgres user, which is the default super user in PostgreSQL. I did not get prompt this time, probably because I uninstalled it before this video just to install it and do this together, you know. But maybe I didn't do it correctly or completely, and I was not prompt this time. So I guess it kept my the credentials I had before. So probably you will see it if it's the first time you're installing it. And with that said, let's start PostgreSQL admin. Just do pgAdmin, you will find it. Let's start it. It's an application that will help us connect to our server that is running on our system, if you have been following this. And we can connect, create databases, have a graphical user interface to see what's happening. It's super cool and awesome. And let's just wait for it to start. Normally, you will be required to unlock pgAdmin. It's password protected. If it's the first time you're running it, you should set probably a password. For me, oh, I can do reset master password. Okay, so this must be what you're watching, what you can see if you are running this for the first time. And let's just set a password so we can use it, and we can see you can connect actually with pgAdmin to multiple different PostgreSQL servers. This is probably it's detecting that PostgreSQL is running on my system, and you should see it too. And you can just give it the password you set for Postgres user. This is what it says, and you can connect. Now we're connected to this server, and we can see the databases, roles, users, and everything. In case you did not see this PostgreSQL 15 or whatever version you have installed server here, it was not auto-detected. You can just go here and do register server and just connect to your local host because that's where it's running by default, and you will definitely see it. It's not hard at all to do. Just provide the password for Postgres. So we're going to create a database. There is actually a default database in Postgres, and every database management system, it is a database to hold information of the server itself, and it needs it to function, so you don't mess with this, just let it be where it is. Okay, we're going to create a new one for our experiments, and let's first create a user. We're gonna do a new login. Let's name it test user. Just give him a password, 12345, I'm gonna put here, and in the privileges, I'll just do can login, nothing else. And I'm gonna save it, and now we have this new user. It's just Postgres, the default one, and test user. And I'm going to also create a new database, and I'm gonna call it testDB, and I'm gonna set the owner as test user for this. Okay, and here's what you see. As I said, the databases have a lot of components. This is a lot of stuff that we don't need right now to interact with it. I'm just going to schemas, which is something like a grouping of tables and other elements of this particular database. And I'm going to tables, which is, I just want to show you that it's empty. There's no tables right now in my database. And we're gonna create one with Python and connect to this with this test user to this test DB, and we're gonna start writing stuff. This is a script I have created with Python to connect to our database. In order to use it, you will need to install SQL Alchemy, which is an object relational mapper, something that bridges object-oriented programming programs with relational databases. Okay, you can read about it. It's something that you can use, and it's very easy to interact with databases with Python. And this, which I want to say, it's called Psycho PostgreSQL 2. I'm gonna take a rain check on the name, how it's pronounced exactly, which is the Python interface to interact with PostgreSQL database specifically. And having these two installed, you can just do pip install these two libraries, and after that you can just use, you can create a URL for your database. We're using PostgreSQL, and we're connecting with test user, the user I just created, with password 12345 at my local host at the default port of PostgreSQL, and we're connecting to testDB. Okay, you just form your URL, the database URL, and you just create an engine with SQL Alchemy create engine. You just parse this URL, and you just do engine.connect, and hopefully if all of this is correct, you will be connected. And after that, I have just created a while true loop that we will use to input queries. Everything that we will put, it's something like a cell. You will see it, we'll run it right now. It's going to just execute it as an SQL query. SQL queries is the language that you communicate with databases and perform transactions. And we're gonna fetch the results. For every execute that you run against a database engine, if you want to see the results, you have to do fetch or fetch all to get the rows from that is the result of your query. I have included this exception for queries that actually are successful but do not return any rows, because this would actually cause an error, this particular error. And now I just do continue to silently continue after that. And this is a greater exception just to catch, whatever else went wrong with my query. And let's see if this is going to work. I'm going to execute it. Okay, connection established. We're connected with this test user, and we can run SQL queries here. Okay, so here's the first thing we're gonna do. We don't have any tables, right? Nothing. We need a table, and we need to execute SQL, PostgreSQL specifically to, create stuff, write data. So here is the query we're going to do first. We're going to create a table that is called users, and it has 4 columns: ID, username, password, and postcode. Okay, it's just an example. You have to define the data type of each column. For example, serial means actually it's a data type that instructs PostgreSQL to auto-increment this specific column. So this is gonna be the ID, and it's I don't need to really, increment it manually. I just, it's gonna be automatically incremented for every row that is added in this table. And the username is a string, let's say, of max 20 characters. It should be unique and not null. This is what all this mean. You can just find the documentation for PostgreSQL. I'm gonna have a password of 32 characters long and a postcode that is an integer. And I have it here just like in one-liner, so we don't have to, I can just copy it and we can see what's gonna happen if we just run this. And we run this query against the server from our program. Remember, this is running right now, it's right here. And if I go now to tables and refresh, we see the users table. And you can view the rows that it has, which is none of right now because we just created the table. But if you do view all rows in pgAdmin, you can have a great view of the data. And let's add some data in this table. And I'm gonna execute the next query, which writes data, insert into, and we're going to insert some information in the users table. And for the username, for example, the value will be Telemachus. For the password column, it will be please subscribe, and postcode will be 99999. We don't need to do ID because it will be auto incremented anyway, so I'm just gonna copy it. And I'm just gonna paste it here, run it, and now if we do play, because what we display here is actually the result of a query. You can also do queries here in pgAdmin, which is extremely useful for a developer. And we can just do play, and we see now that we have one row, Telemachus, please subscribe, and everything. Let's do one more just for fun. This one will be admin. Also, he wants to subscribe, and I don't know, something else here. And I'm gonna do play again, and admin will also be here. So this is how you can have a Python script, and the philosophy is the same with other programming languages as well, and connect with an application to a database, write stuff by executing queries. There are other ways to execute queries, not just the raw strings, but I just do this right now so we can, use a little bit of SQL as well, because it's really fun and useful. And this is a simple example. You can just grab it and create whatever application you want that may want to connect to some server and write information or retrieve them. For example, we can retrieve with select everything from users, the users table. Be sure to add a semicolon because SQL is very sensitive about finishing scripts with, semicolons. And if I do this, I can see that I fetched all of the rows from this table. And this is in Python, it's just a list of tuples, and you can just, navigate through them, grab the values that you're interested in, and use them in your program. As I said, you could also execute this query from pgAdmin. We edit this. We will just need to use maybe query tool, go here, and we'll add this line, and I will change it again to something random. Whatever, and this can be the same, it doesn't really matter. And after this finishes, we're gonna do select everything from users, just to be able to see the results. SQL is not case sensitive, but it's really great for other people also, and yourself, to be able to read queries clearly, to just follow this standard. And I'm just gonna do play, and now we have 3 rows, and we added this junk also here. If this video was useful to you, you can just support a little bit my channel by subscribing, or follow me on GitHub and check out other projects I've made. There's plenty of mainly cybersecurity stuff in here. You can just download them and use them. There are password list generators and C2 frameworks and XSS exploitation tools and stuff like that. Just check it out, and thanks for watching.